Section 2.2, example 9, using the disk method to find the volume of the solid of revolution, part 2. Let R be the region bounded by the graph of G of Y. Ooh, we're in terms of Y again. G of Y and the Y-axis, this time over the Y-axis interval from 0 to 4. So everything's already in the Y in terms of Y, so we don't have to switch between X's and Y's. We could just take everything as it is. So use the disk method to find the volume of the solid of revolution generated by rotating R around the X-axis. All right, so we don't have to do anything crazy. You could graph it if you want to, but in this case, we could just take it for what it is. So integrating with respect to Y from 0 to 4, we're looking at the Y-axis. So the radius is going to be, so pi times r squared. The radius is going to be whatever we are evaluated at that point. So looking at it from the square root of 4 minus y dy. And it looks like we can't just integrate this part. Oh, I'm sorry. We could, because we're squaring it. So pi r squared. So we're squaring that part, making it a lot easier. So let's pull that pi out in front of the integral. So integrating 4 minus y dy. Pi times 4y minus 1 over 2y squared, evaluated from 0 to 4. And let's integrate or evaluate at 4, then subtract the evaluating at 0. So evaluated at 4, we have 4 times 4 minus 1 over 2, 4 squared, minus 4 times 0 minus 1 over 2 times 0 squared. Pi times 4 times 4 is 16, minus 4 squared is 16 divided by 2 is 8. And then those parts are 0. So we have 8 pi. Let's see, yep, 8 pi. That is it. If you happen to have any questions, please feel free to ask. Otherwise, bye.